From the Earth to the Moon by Jules Verne. Chapter 5. The Romance of the Moon. An observer endued with an infinite range of vision and placed in that unknown center around which the entire world revolves might have beheld myriads of atoms filling all space during that chaotic epoch of the universe. Little by little, as ages went on, a change took place. A general law of attraction manifested itself, to which the hitherto errant atoms became obedient. These atoms, combined together chemically according to their affinities, form themselves into molecules, and compose those nebulous masses with which the depths of the heavens are strewed. These masses became immediately endued with a rotary motion around their own central point. This center, formed of indefinite molecules, began to revolve around its own axis during its gradual condensation. Then, following the immutable laws of mechanics, in proportion as its bulk diminished by condensation, its rotary motion became accelerated, and these two effects continuing, the result was the formation of one principal star, the center of the nebulous mass. By attentively watching, the observer would then have perceived the other molecules of the mass, following the example of this central star, become likewise condensed by gradual accelerated rotation, and gravitating round it in the shape of innumerable stars. Thus was formed the nebulae, of which astronomers have reckoned up nearly 5,000. Among these 5,000 nebulae there is one which has received the name of the Milky Way, and which contains 18 millions of stars, each of which has become the center of a solar world. If the observer had then specially directed his attention to one of the more humble and less brilliant of these stellar bodies, a star of the fourth class, that which is arrogantly called the sun, all the phenomena to which the formation of the universe is to be ascribed would have been successfully fulfilled before his eyes. In fact, he would have perceived this sun, and yet in the gaseous state, and composed of moving molecules, revolving round its axis in order to accomplish its work of concentration. This motion, faithful to the laws of mechanics, would have been accelerated with the diminution of its volume, and a moment would have arrived when the centrifugal force would have overpowered the centripetal, which causes the molecules all to tend toward the center. Another phenomenon would now have passed before the observer's eye, and the molecules situated on the plane of the equator, escaping like a stone from a sling of which the cord had suddenly snapped, would have formed around the sun sundry concentric rings resembling that of Saturn. In their turn again, these rings of cosmical matter, excited by a rotary motion about the central mass, would have been broken up and decomposed into secondary nebulocytes, that is to say, into planets. Similarly, he would have observed these planets throw off one or more rings each, which became the origin of the secondary bodies which we call satellites. Thus, then, advancing from atom to molecule, from molecule to nebulous mass, from that to principal star, from star to sun, from sun to planet, and hence to satellite, we have the whole series of transformations undergone by the heavenly bodies during the first days of the world. Now, of those attendant bodies which the sun maintains in their elliptical orbits by the great law of gravitation, some few in turn possess satellites. Uranus has 8, Saturn 8, Jupiter 4, Neptune possibly 3, and the Earth 1. This last, one of the least important of the entire solar system, we call the Moon, and it is she whom the daring genius of the Americans profess their intention of conquering. The Moon, by her comparative proximity, and the constantly varying appearances produced by her several phases, has always occupied a considerable share of the attention of the inhabitants of the earth. From the time of Thales of Miletus in the 5th century B.C., down to that of Copernicus in the 15th, and Tycho Brahe in the 16th century A.D., observations have been from time to time carried on with more or less correctness, until in the present day the altitudes of the lunar mountains have been determined with exactitude. Galileo explained the phenomena of the lunar light produced during certain of her phases by the existence of mountains, to which he assigned a mean altitude of 27,000 feet. After him, Hevelius, an astronomer of Denstic, reduced the highest elevations to 15,000 feet, but the calculations of Riccoli brought them up again to 21,000 feet. At the close of the 18th century, Herschel, armed with a powerful telescope, considerably reduced the preceding measurements. He assigned a height of 11,400 feet to the maximum elevations, and reduced the mean of the different altitudes to little more than 2,400 feet. But Herschel's calculations were in their turn corrected by the observations of Halley, Nasmyth, Bianchini, Grucian, and others, but it was reserved for the labors of Boer and Madelaire finally to solve the question. They succeeded in measuring 1,905 different elevations, of which 6 exceeded 15,000 feet, and 22 exceeded 14,400 feet, the highest summit of all towers to a height of 22,606 feet above the surface of the lunar disk. At the same period the examination of the moon was completed. She appeared completely riddled with craters, and her essentially volcanic character was apparent at each observation. By the absence of refraction in the rays of the planets occulted by her, we conclude that she is absolutely devoid of an atmosphere. The absence of air entails the absence of water. It became therefore manifest that Selenites, to support life under such conditions, must possess a special organization of their own, must differ remarkably from the inhabitants of the earth. At length, thanks to modern art, instruments of still higher perfection searched the moon without intermission, not leaving a single point of her surface unexplored; and, notwithstanding that her diameter measures 2,150 miles, her surface equals the 1/15th part of that of our globe, and her bulk the 1/49th part of that of the terrestrial spheroid. Not one of her secrets was able to escape the eyes of the astronomers, and these skilful men of science carried to an even greater degree their prodigious observations. Thus they remarked that, during full moon, the disk appeared scored, in certain parts, with white lines, and during these phases with black. On prosecuting the study of these with still greater precision, they succeeded in obtaining an exact account of the nature of these lines. They were long and narrow furrows sunk between parallel ridges, bordering generally upon the edges of the craters. Their length varied between 10 and 100 miles, and their width was about 1,600 yards. Astronomers called them chasms, but they could not get any further. Whether these chasms were the dried-up beds of ancient rivers or not, they were unable to thoroughly ascertain. The Americans, among others, hoped one day or other to determine this geological question. They also undertook to examine the true nature of that system of parallel ramparts discovered on the moon's surface by Grothusian, a learned professor of Munich, who considered them to be a system of fortifications thrown up by the Selenitic engineers. These 2 points, yet obscure, as well as others, no doubt, could not be definitely settled except by direct communication with the moon. Regarding the degree of intensity of its light, there was nothing more to learn on this point. It was known that it is 300,000 times weaker than that of our sun, and that its heat has no appreciable effect upon the thermometer. As to the phenomenon known as the ashy light, it is explained naturally by the effect of the transmission of the solar rays from the earth to the moon, which gives the appearance of completeness to the lunar disk, while it presents itself under the crescent form during its first and last phases. Such was the state of knowledge acquired regarding the earth's satellite, which the Gun Club undertook to perfect in all its aspects, cosmographic, geological, political, and moral. End of chapter 5.